In this video, I will be discussing my theory of quantum gravitational mechanics. Some of it naturally contains various existing theories, but the main principle is my own conclusion of this lengthy battle. I must forewarn, this video isn't for the scientifically illiterate, it requires a moderate level of education in physics. Anyway, to explain my theory, there are three main things to contemplate simultaneously: general relativity, special relativity, and the Heisenberg uncertainty principle. So, number 1. General relativity states that any object with mass generates a gravitational field around it, imparting the effect of time dilation increasing with intensity in proximity to such objects. This is quantified by a simple equation. The square root of 1 minus 2 multiplied by the gravitational constant multiplied by the mass of the object divided by the distance from the center of the object multiplied by the speed of causality squared. Got it? Good. Number 2. Special relativity states that objects experience relativistic effects, increasing in intensity in an exponential fashion as the speed of causality is approached, but never achieved if they have the property of mass. Number 3. The Heisenberg uncertainty principle defines the impossibility to observe the position and momentum of a given particle with perfect accuracy. Take the electron, for example. It does not orbit its parent nucleus akin to a planet orbiting a star. Instead, it exists in a three-dimensional standing wave of probable locations according to the mathematical functions of this uncertainty principle, in particular shapes according to the s, p, d, and f orbital configurations. This causes the effect of simultaneity, where particles can exist in multiple locations at the same time. Einstein's curved spacetime. Albert Einstein was correct and accurate in reference to his field equations as a practical scientific model of reality with predictive capability, but he isn't entirely correct in his contention that gravity is caused by a curvature in spacetime. This curvature of spacetime is subject to interpretation. The main contention is that it isn't spatial curvature, but a curvature in time. But the derivation of a gravitational mechanism from a mere curvature in time alone isn't logical or possible. If space was curved in this manner, shouldn't we observe photons following a trajectory similar to the black line in the schematic here? However, we observe the phenomena of orbiting bodies, and if spacetime curving was the cause of this, surely they should continue to orbit at the same altitude at any velocity without falling to the surface. We know that satellites travel fast enough that the Earth's surface curves away from them at the same rate at which they fall. Also, say we were near an extremely dense celestial object such as a neutron star, and we had a length of rigid material such as the hardest metal known to man, surely due to the apparent curved spacetime, shouldn't it bend as it approaches the neutron star and return to normal once it moves away? If the theory of curved spacetime implies that extra dimensions are needed to explain its mechanism, this just pushes the problem into a different dimension. It is akin to two-dimensional beings arguing that gravity is due to curved three-dimensional space in a direction they cannot access or comprehend. But the third dimension reveals a ramp that objects roll down and project onto the second dimension, and since the gravitational force is still there, but it is just acting in a direction that is unknown to the second dimension, the mechanism is still unknown, but as far as two-dimensional philosophers are concerned, they are satisfied with their explanations, but all they have done is alleviate themselves of the responsibility to discover the mechanism of gravity. This is exactly the same in these demonstrations of space-time curvature, where an elastic sheet is stretched out and heavy objects are placed upon it. Viewed directly from above, or from two-dimensional beings living on its surface, the mysterious force of gravity draws objects towards the central mass, and it would appear that the force originates directly from the mass, even though three-dimensional beings can see that it is a curvature in the fabric that causes it. But in reality, the gravitational force is coming from a direction imperceptible to the two-dimensional beings, and the true mechanism of gravity would still be unknown. The two-dimensional beings can drive themselves insane trying to understand three-dimensional geometry, or be conceited enough to claim that they do, and even attempt to baffle others with ostentatious mathematical nonsense with the assertion that the conception of three dimensions is impossible without achieving a comprehensive understanding of such gibberish. but ultimately they are still bereft of the truth. Strictly speaking, gravitational waves warping space-time shouldn't be possible to detect. The instruments of measurement should be correspondingly warped in the same exact magnitude. This is not what we observe, and these effects are apparent in celestial bodies. When gravitational waves pass through a star, the interior is mashed around, resulting in a rise in temperature. If it was the fabric of space being warped by gravitational waves, the distances of interaction between the particles wouldn't be affected in any significant way, since all of the spatial fabric is being affected, not just the spaces between the particles. The particle clouds themselves and the effective distances of interaction are also being warped and compressed to the same degree. Higgs mechanism. The Higgs mechanism to describe mass is, in my opinion, unconvincing. It is absurd to say that mass comes from certain fundamental particles choosing to interact with some arbitrary field, as Neil deGrasse Tyson describes it, like a popular person trying to make his way through a party with everyone wanting to slow him down and shake his hand. Intuition causes me to speculate that if the Higgs field was interacting with particles giving them resistance to changes in motion, then shouldn't it also cause resistance to motion altogether, causing anything with mass to slow down and stop? Surely if energy is being lost to the Higgs field, then isn't the conservation of energy being violated? No energy or particle has ever been directly observed to interact with this Higgs field, and the only evidence for the Higgs boson is the apparent detection of decay products that, it has been claimed, originated from a Higgs boson, after scientists did nothing more than smash protons together in the Large Hadron Collider. Other than the detection of these decay products, everything about the Higgs mechanism is purely theoretical. Since the Higgs boson decays into 2 Z bosons, which then decay into 4 leptons, I think it's more reasonable to say that the Higgs boson is nothing more than a higher energy Z boson, especially since its decay mode is basically the same. It has been claimed that the Higgs field gives particles mass, and mass is responsible for gravity. Except that photons don't interact with the Higgs field, yet they produce a gravitational field according to Einstein's stress-energy tensor, and the Higgs boson doesn't gain its own mass from the Higgs field, somehow getting its mass from elsewhere. The current theory seems to be that gravity is the result of a curvature in space-time, and mass comes from particles interacting with the Higgs field. However, gravity and mass in non-inertial frames of reference are intrinsically linked, and the effects are equally proportional to each other. If these forces are independent of each other, then surely they should differ to some extent. An object free-falling in a gravitational field of 1g accelerates at a velocity of 9.8 meters per second squared, and an object accelerating at 9.8 meters per second squared experiences g-forces of 1g. Since these effects are exactly equal, the mechanism must be the same in some way, unless this highly unlikely coincidence exists, being that the effects of the Higgs mechanism and spacetime curvature are exactly equal. Also, if the Higgs mechanism is responsible for resistance to changes in velocity, shouldn't it apply to objects falling in gravitational fields? If these forces are independent of each other and happen to differ from each other in magnitude, then objects should feel g-forces as they accelerate towards a gravitational object. The derivation of a gravitational theory from the Higgs mechanism has not been proposed in an official capacity. No proposals have been put forward attempting to link the manifestation of mass from the Higgs field to the theoretical curvature of spacetime that people believe is responsible for gravity. Refuting various theories. There are a few alternative theories of gravity, most of which aren't taken seriously by the scientific community. They are as follows. The Brans-Dicke theory. This is just an alternative to Einstein field equations, nothing more than a model of reality with predictive capability, parts of which have been refuted by observational evidence. It does not attempt to explain the mechanism of gravity. Induced gravity. This theory talks about the fabric of space-time being a loop quantum entanglement. No real mechanism of gravity is explained other than space-time curvature resulting from quantum degrees of freedom. String theory. Similarly, this is just a theory on how the fundamental particles of matter are made of one-dimensional strings. The mechanism of gravity is also based on non-existent gravitons. FR theory. Just another alternative predictive model and set of alternative field equations based on general relativity. No real alternative gravitational mechanism is submitted. Horndeski theory, an attempt to explain gravity with extra dimensions, which again is just pushing the problem into another dimension. Supergravity, another extra-dimensional theory. It is a modern field theory that combines the principles of supersymmetry and general relativity combined with super Poincare algebra to make a gravitational theory that is supported with extra dimensions, or in other words, academic responsibility has been discharged into extra dimensions. You may remember Henry Poincare from his conjecture that was eventually solved by Grigori Perelman, who was an extremely obese hermit who shut himself in his room for decades, completely obsessed with donuts and the geometric topology of them when overfilled with jam. Non-symmetric gravity theory, predictive model alterations for the flat rotation of galaxies. No alternative gravitational mechanism is submitted. Tensor vector scalar gravity theory, another predictive model based on modified Newtonian dynamics, which has been proven to be observationally incorrect. This is still based on space-time curvature. Chameleon theory, a new crappy non-existent particle similar to the graviton. Pressuron theory, another new crappy non-existent particle similar to the graviton. Conformal gravity, alternative models based on space-time curvature using Weyl transformations instead of the Ricci scalar. Still curved space-time. Entropic force gravity just talks about how the weak gravitational field at enormous distances transforms into linear decay rather than inverse square law closer to celestial objects. Superfluid vacuum theory, no real gravitational mechanism submitted, just postulation on the physical vacuum being a superfluid or a Bose-Einstein condensate, despite being devoid of matter. Massive theory, another theory on gravitons, except that they apparently have non-zero mass. Modified Newtonian dynamics, not observationally proven as a model of reality with predictive capability. Moffat's theory, some delusional Canadian physicist gets spasticated on crack cocaine and scribbles a disorganized jumble of crap, talking about how the speed of light is a trillion times faster in the distant past, and how gravity is extremely strong at its source but then is counteracted by a mysterious repulsive fifth force at a larger distance. A lot of these theories are just assortments of physicists whinging about which equations accurately describe the forces of gravity and predictive mechanisms that could be used to, for example, anticipate the movements of celestial bodies, calculate space missions, and determine relativistic effects on matter. A few of these theories, and a lot of suggestions in the scientific field, try to point towards the existence of a particle that modulates gravity, known as a graviton. No one has ever detected or observed a graviton, and I don't see how it could mechanically function. So we have gravitational interaction between mass 1 and mass 2. So mass 1 would have to emit gravitons, which travel out at the speed of light, interact with particles in mass 2, somehow tell them to accelerate in a certain direction, and return to mass 1? These gravitons must return to mass 1, otherwise mass 1 would persistently lose energy and therefore mass. And since gravitons return to the source, what makes them return, and how do they find their way back to the source? Once they interact with a particle, they start going backwards in the same exact trajectory? Why is it not possible to detect gravitons if they are interacting with matter all the time to produce gravitational effects? Personally, I find it impossible that gravitons might exist at all. All of these theories are just some kind of variation of dimensional procrastination or graviton schizophrenia, and others are either different ways of presenting Einstein field equations or just go on about weird theories on the quantum constituency of matter without really attempting to explain the mechanism of gravity in a way that can be readily understood. It seems that physicists are spending all of their time wrestling with equations that predict the trajectories of celestial objects and relativistic effects, rather than trying to work out how gravity actually works. My theory: particles with mass emit a three-dimensional isotropic time dilation gradient. Even massless particles emit gravitational fields. Time passes slower as you gain proximity to any object with mass. Keep in mind that this is a relativistic effect that can be measured by outside observers, but locally speaking in any reference frame, time appears to pass normally, regardless of how close to the speed of causality one may be travelling at. or the intensity of a gravitational field they may be in. All particles are distributed in a cloud of probabilistic locations according to their shell configuration, existing simultaneously in all, each, either, and none of these possible locations within the probability distribution, even if the cloud configurations are physically separated by voids of space. This was demonstrated to be correct in the double-slit experiment. The compliance of causality and the maintenance of physical constants is likely to be the mechanism of gravitation. If we use an electron as an example to work with, we can put it in a gravitational field and try to work out what's going on. We know that if it exists next to an object with mass, it will exist in a gradient of time dilation. Also, all particles exist in a cloud of quantum superpositions, distributed in a mathematical function of probabilistic locations so that they exist simultaneously in differing locations, such as location A and location B. In location A, the electron's quantification of the speed of causality would be faster than what it would observe in location B, but because of the Heisenberg uncertainty principle, the electron exists in both locations A and B simultaneously, therefore experiencing two different intensities of relativistic effects at the same time. The speed of causality is a universal constant and cannot be violated, and any observer must always measure the speed of light in a vacuum to be 299,792,458 meters per second, regardless of their velocity or proximity to a gravity field. So if the electron observes C to be 299,792,458 meters per second in location B, the gradient in time dilation should cause location A to experience the speed of causality to be faster than 299,792,458 meters per second relative to location B, but this is impossible. The only way to account for this discrepancy is for location A to accelerate further into the gravitational field. Gravity is weak because the time dilation gradient is slight, the particle clouds are small, and the accelerative response is only proportionate to the difference in time dilation. This isn't just exclusive to these two locations. The entire electron is in a gradient, so for each Planck second that passes, each individual Planck length in the electron cloud steps down towards the mass to equalize the time dilation discrepancy. This is also apparent and equivalent in accelerating reference frames. If an electron is accelerating at 9.8 meters per second squared, the force propagates across the electron limited by the speed of causality, and thus location B is always traveling faster than location A. The diameter of a free electron is 5.4 femtometers, so the time it takes for light to travel that distance is 1.87 times 10 to the minus 23 seconds. The distance and therefore the disparity in the magnitude of time dilation is incredibly tiny, but the difference is still there. Since location B experiences the speed of causality to be 299,792,458 meters per second, location A should experience the speed of causality to be faster than 299,792,458 meters per second. But again, this is impossible. Whenever accelerating, the electron fights back with a resistive force, manifesting as a corresponding acceleration in the opposite direction to maintain equilibrium of the causality constant across the gradient of time dilation. This is equivalent to an electron resting upon the surface of mass m, in the same way that non-inertial reference frames are equivalent to objects accelerating in gravitational fields. I've always found it very strange that objects can accelerate without feeling any g-forces in gravitational fields, but obviously it's due to proportionate relativistic responses to time dilation gradients in the probabilistic distribution clouds of particles, causing every electron and quark in the object to accelerate together at the same rate. This applies to photons as well as all particles on the Standard Model. Classically speaking, photons shouldn't respond to gravitational fields because they do not exhibit the property of mass. But since the Heisenberg uncertainty principle applies to all particles, the photon should respond the same way in regards to time dilation gradients, as demonstrated by Einstein's stress-energy tensor. This theory also intrinsically explains the origin of mass, since mass is partially defined as resistance to changes in motion. There is no need for the Higgs field and its ridiculous contentions.
I am God!
This theory also accounts for the apparent transformations of mass and energy. An up quark has a mass of 2.2 megaelectron-volts divided by the speed of light squared. A down quark has a mass of 4.7 megaelectron-volts divided by the speed of light squared. and thus the constituent parts of a proton add up to 9.1 megaelectron-volts divided by the speed of light squared. But the observed mass of a proton is 938.28 megaelectron-volts divided by the speed of light squared. How can it be around 100 times more? Apparently 99% of the mass of a proton is tied up in the vibrational, kinetic and binding energy of the quarks and gluons respectively, but I can't see the reasoning why vibrations, kinetic energy or binding energy would translate into 100 times more mass. It's like saying rubber bands weigh 100 times more if they are vibrating, stretched out or travelling at speed. However, if the Higgs mechanism of mass was true, the proton's mass would still only be 9.1 megaelectron-volts divided by the speed of light squared, since quarks alone interacting with the Higgs field is the only reason why mass arises, regardless of what they are doing. If the Higgs mechanism is the only way things can attain mass, why is it responsible for only 1% of a proton's intrinsic mass, and the origin of the 99% is basically unknown and blamed on other modes of energy somehow translating into mass without a satisfactory explanation? But if we apply my theory to the configuration of a proton's structure, quantum chromodynamics, and the Heisenberg uncertainty principle spreading the proton's constituent parts over the volume of the proton, the answer is profoundly significant. The width of an UP quark is 8.6 times 10 to the minus 16 meters. Additionally, the width of a proton is 1.7 times 10 to the minus 13 meters, which is approximately 100 times wider than the UP quark, and since it has approximately 100 times the mass for no apparent reason, a reasonable explanation is that the quarks are spread over 100 times the width that they normally occupy over the same time dilation gradient, thus exhibiting 100 times the mass of the constituent parts. The weakness of gravity is also explained in this theory, as it is 10 to the power of 36 times weaker than the electromagnetic force. Time dilation gradients are very slight on small celestial objects such as the Earth, and particle clouds are very small. The effect of time dilation on Earth for clocks placed on the ground and 1 kilometer in altitude is quantified to be 3 microseconds per year, and the classical radius of an electron is 2.81 times 10 to the minus 15 meters. The difference in the flow of time in location A and location B is minuscule, but it still exists. Also, gravity isn't the only property of matter that is relatively weak. Mass and its resistance to changes in motion is proportionately weak in equal amounts. If only gravity was weak, normal matter would take incredible amounts of energy to move around, as if objects were stuck in a 5 Tesla magnetic field. As I said in the beginning, Einstein's field equations are still accurate descriptors of reality, but the actual mechanism of gravity is still considered to be unknown. For example, gravitational waves still function in the same observational manner, but since everything in the universe is still limited by the speed of causality, time dilation gradients still travel at the speed of light. But instead of them being the curvature of space-time, it is varying gradients of time dilation imparting the effects discussed previously. Since I live in Luton, it is impossible to meet anyone who has the faintest idea of what I am talking about, so let me know what you think in the comments, particularly if you have any thought experiments that either prove or disprove parts of my theory.
Attempted murder. Now, honestly, what is that? Do they give a Nobel Prize for attempted chemistry, do they?